Hello guys! Today we're going to speak about sample and statistical population. So, what is the main goal of statistics? Briefly speaking, we try to test hypotheses about the world using only a small part of information available to us. For instance, suppose we decide to estimate the average height of a male in Russia. Actually, Russia is a relatively huge country, and it would be a very difficult and boring task to measure the height of each male in the country. The fundamental idea of statistics tells us that we are able to find the answer using only a part of all the data. In our case, we can select a group of males called a sample, get the average height of this sample, which is called sample mean, and use this value to estimate the average height of all the men in the country. Obviously, this approach immediately raises some questions. For example, how should we form the sample? How sure are we that the sample average height is close to the average height of all men? Can we say anything about the accuracy of our estimation? All these questions actually are the main topic of our course, and we will answer them soon. Actually, we have already introduced some concepts in statistical population, sample, parameter, and statistics. Let's clear up these definitions one by one. The set of all objects that we want to draw a conclusion about is called the statistical population. In other words, statistical population is a set of all objects which you want to generalize your result on in a scientific or applied study. Objects in the statistical populations have different properties. In our example, men can have height, weight, salary, marital status, and so on. Such properties are called parameters and are traditionally denoted by Greek letters. The average height of the statistical population is called a parameter. As an example, the average value in the statistical population is denoted by the Greek letter nu. Generally, we don't have any access to all the objects in the statistical population, and the parameters which we are interested in are unknown. To estimate the unknown parameters, a researcher forms a sample. A sample is a set of observations selected from the statistical population in accordance with special rules. Then we can use the sample to make an inference about the whole population. For instance, we can use average height in our sample to estimate the unknown parameter of the population. The sample mean is an example of what we call a statistics. Pay attention to the fact that the word statistic has no different meanings. Statistics is a science and is also a characteristic of the sample. However, you might still be wondering, how is it possible to draw a reasonable inference about the statistical population using only sample data? Actually, this is the main question of the course. Now, let's try to get the main idea of the process. Imagine that an unknown picture is the statistical population we wanted to study, and that each small part of the picture is an element of the population. Let's try to form a sample to understand the meaning of the whole picture. Consider a situation when we selected a sample, but we had used only the parts from the right side. Obviously, it's still hard to understand what's going on here. As a result, the mere fact that we have a huge sample doesn't mean that our sample reflects the statistical population properties. More importantly, the procedure should be random. For instance, each element in the general population should have the same chance of becoming an element of the sample. Let us consider another example of the sample. Now we choose n elements in a random manner. We can see that the sample is still just a part of the whole population, but it really does reflect it now. As a result, you can understand what's going on. If the sample reflects the properties of the statistical population, the sample is called representative. Even a small but representative sample can reflect the population properly.